This is a continuation of the factoring strategy video, and this is video number 2. So for number 3, I've got 64a minus 8a squared plus 8a cubed. And if you notice right away, this isn't actually already set up for factoring. So perhaps in my strategy I should have said, first check to see if it's in descending order of powers, because I can't start my factoring strategy until the problem is set up in the correct order. So that's the first thing I'm going to do. I'm going to reorder it in descending order of powers, so it becomes 8a cubed minus 8a squared plus 64a. Now I can start asking myself the questions from our factoring strategy. And the first one, of course, is, do I have a factor in common to all 3 of my terms, or is there a GCF? And yes, there is. 8 goes into all 3 of those terms, and so does a. So I'm going to factor out 8a, and that leaves me a squared minus a plus 8. I factored 8a out of all 3 of my terms. And now I look at what I have left in my parentheses, and the next step is count your number of terms. I have 3 terms, and remember, with 3 terms we're looking to see first, is it a perfect square trinomial? And no, it's not, because while the first term is a perfect square, the last term is not, so it can't be a perfect square trinomial. That means I'm going to use the T-chart or AC method. The T-chart method, if I don't have a leading coefficient here that's not 1, obviously my leading coefficient is 1, I just have to check, do I have anything that multiplies to 8, the end term, and adds to the coefficient of the middle term, which is negative 1. I don't need to multiply the number in front of a squared because it was just 1. So I'm looking for 2 numbers that will multiply to 8 at the same time that they add to negative 1. Well, nothing's coming to mind, so I want to check the possible factors of 8. I have 1 and 8, and I have 2 and 4. And no matter how I negate those, what I make positive and what I make negative, there is no way to make those equal negative 1 when I add them together. That tells me, and remember, this is just a strategy for finding your numbers. If you can do those in your head, you don't need to write the T-chart. It's just meant to help you when you're having difficulty finding the numbers. But since there were no 2 numbers that multiplied to 8 and added to negative 1, that means this is already fully factored. I can't say it's prime, remember, because I already factored out a common 8a. The fact that the trinomial that's left in there is prime does not make the whole problem prime. So I have finished problem number 3. To check it, of course, I would multiply that back. Problem number 4 is in descending order of powers, so I'm ready right away to start looking for a GCF. So I'm looking at 6, 8, and 8. The only thing in common is a 2, so I'll factor 2 out of all 3 of those. And then I have m cubed, m squared, and m, so I have an m in common to all of those. So now I'm going to divide or factor that out. 6 divided by 2 is 3. M cubed divided by m is m squared. 8 divided by 2 is 4. M squared divided by m is m. You notice that I'm just bringing down the same sign, so I'm bringing down a subtraction next. That's because I did not factor out a negative, so I'm not changing my signs. 8 divided by 2 is 4 again, and m divided by m cancels out. They make 1, but I don't need to write the 1 in there. So now, what I have in parentheses is a trinomial. With a trinomial, the first thing I'm looking for, remember, is a perfect square trinomial, which this is not, because the first term, 3, is not a perfect square. It does not have a square root. That's a whole number. So now I'm going to check the next thing, and that is the T-chart or AC method. I call it the T-chart method because I draw a T-chart like you can see that I did right here. So I have 3m squared minus 4m minus 4. I have a leading coefficient that's not 1, so that means I'm multiplying the first term times the last term. That gives me negative 12. I'll write over here. Draw my T-chart. I have to find 2 factors that multiply to negative 12 and add to the middle term, which is negative 4. So again, 2 numbers that multiply to negative 12 and add to negative 4. If they came to mind already for you, you didn't need to write out your T-chart. I think they came to mind for me right away. I think negative 6 and positive 2 multiplies to negative 12, and negative 6 plus 2 adds to negative 4. So those are my two numbers. If the first thing you think of doesn't work, then try another combination in the same way that I did for problem number 3. So remember, when you have a leading coefficient and you use this T-chart or AC method, the next step is to use grouping. So I'm going to bring down my 2m, and now I'm going to use the two numbers that I found, the negative 6 and the positive 2, to break negative 4m down into two terms. So I have 3m squared, and I'm going to say minus 6m plus 2m minus that last term I'll bring down, which is 4. Should have put a bracket there, shouldn't I? Okay, negative 6m and positive 2m make negative 4m when I add them, and that's what I wanted to do, is add those two numbers to be my middle term. So now I'm going to use grouping. So let me erase my work over here so I've got some more space. Erase this so I've got some more space. Okay. I am going to look for what's in common between 3m squared and 6m, and that's 3m. And what I have left, 3m squared divided by 3m is m. 6m divided by 3m is minus 2. I didn't factor out a negative, so I don't need to change that sign. And now, I need to have in my second set of parentheses, after I factor that, m minus 2. I have 2m minus 4, so I can factor out a positive 2, and that leaves me m minus 2. I can't forget that 2m I factored out at the beginning. You don't want to forget something you factor out as a GCF. So now, on grouping, my next step is to look at the two terms I now have remaining here and see if they have a GCF, which is what I was attempting to get, was what was in the parentheses to be the same thing. It is, it's m minus 2, so I factor that out. And then what's in front of the parentheses, or when I take 3m times the quantity m minus 2 and divide out the m minus 2, I'm left with 3m. Same thing over here. I take 2 times the quantity m minus 2 and divide out my m minus 2, and I'm left with plus 2. Again, bring down your original 2m, and I have 2m times the quantity m minus 2 times the quantity 3m plus 2. I look in each of my parentheses, m minus 2, not a difference of two perfect squares, doesn't have a common factor, so that one's fully factored. 3m plus 2, again, doesn't have a GCF in there and does appear to be fully factored. So it appears that I am done with that problem, and I of course can multiply it back to see if I get my original problem. So here is my final answer. My next example is 2y squared minus 8. First thing I ask myself on every factoring problem is, do I have a GCF? And looking at 2 and 8, I do. I have a 2 in common. I divide 2 into 2, I get 1. That leaves me just y squared. I divide 2 into 8, and I get 4. So now I count my terms. I have 2 left. What I'm looking for two terms is a difference of two perfect squares. Y squared is a perfect square. 4 is a perfect square. So it is a difference of two perfect squares. If you remember the rule for factoring a difference of two perfect squares, I take the square root of the first for both parentheses. I take the square root of the last for both parentheses, once with a plus sign, once with a minus sign. Bring down the 2 that I factored out, and I appear to be done. I'm going to look at this set of parentheses. There's nothing factorable in here. I didn't miss a GCF. That was in this set right here. I look at this set again. Doesn't appear that I missed anything. So it looks like that's my final answer. Of course, remember to FOIL back y plus 2 times y minus 2. Multiply in the 2, and you can check your answer. This is video 2 on a factoring strategy. Be sure to check for video 3.